My name is Cassia Barnard, and I'm currently a student at the University of Florida. Over this past year, I've been working with Dr. Matthias on a 20-year rainfall climatology and an analysis of Hurricane Maria over the island of Dominica. I chose Dominica as my region of study because I was born and raised here, and I have friends and family who are currently living on the island. So Dominica is located, if we look here in Figure 1, is located in the Caribbean. It is in the Lesser Antilles between Martinique and Guadeloupe, and it is 637 kilometers away from Puerto Rico. Due to its location, it is pretty vulnerable to strong winds, heavy rains, and flooding. And also in the Caribbean, tropical cyclones are pretty frequent in occurrence, and so the rainfall that they bring contribute to the Caribbean's rainfall climatology. Hurricane Maria brought 579 millimeters of rain, according to the National Hurricane Center, and this significantly impacted Dominica's population and their infrastructure. So a personal example of this is I have a friend whose home was completely destroyed during Hurricane Maria, and for the past 4 years, she's been living out of a tent with no electricity or running water. And just this year, she's able to start rebuilding her home, so that's pretty exciting news. Lastly, of my research reviews, there have been numerous studies on tropical cyclones and rainfall for places like Puerto Rico or other more commonly known Caribbean islands, but very few studies have been done. So the research questions that I had hoped to answer was basically how much rain came across the island. And to do this, I needed to be able to compare different locations across the island. So if we look here in Figure 2, the data that I used came in a gridded format. And so each of these boxes are grid cells, and each grid cell is 1/10 of a degree latitude by 1/10 of a degree longitude. And the color scheme used here is just to signify the outline of each grid cell. And I'll explain more about this figure and the data set in my data and methods. So the other research questions I had was how long did Hurricane Maria produce rain across the island, how much rainfall was produced at each location, and which location received the most amount of rain, and lastly, was there more rain before or after Hurricane Maria made landfall? How I went about to answer these questions was I obtained data from 2 different sources. The first being NASA, where I downloaded integrated multi-satellite retrievals, or iMerge data, for a 20-year monthly period and for a 3-day half-hourly period. So iMerge, like any kind of data set, has its limitations. And because iMerge is basically a whole bunch of sensors that are merged together to produce this data set, and that there's multiple satellites being used at different times, variation in the data could occur because of the moving satellites around the globe. The other source that I obtained data from was the National Hurricane Center, and this just gave me my extra information on Hurricane Maria, specifically the total amount of rainfall and the time of landfall for Hurricane Maria. How I analyzed this data was I used a Geographic Information System, or GIS, to extract the rain rate values of the 14 grid cells that intersected with the island. So like I mentioned previously, the data set came in a gridded format. And looking back here at Figure 2, once I extracted the rain rate values in each of the 14 grid cells, I was then able to match the closest town for each grid cell. So for example, Roseau here in this orange cell is just one of the grid cells, and it also happens to be the capital of Dominica. Another example is Soufriere down here in this green grid cell, which is where I was raised. And just a final example, which will make more sense as I reach my results, is Marigot here on this eastern side. So once I was able to match the closest towns or village in each cell, I was then able to calculate a 20-year average for the monthly data set. And then for the 3-day data set, I was able to determine the start and end times of rainfall across the island, and then made a raster layer to visualize the rain bands, which we can see here in Figure 4A through C. So how I split my results was into 2 different sections. The first that I'll talk about is the 20-year rainfall climatology. So first off, rainfall is going to be highest on the eastern side of the island. So that's going to be over on this side. And also the highest amount of rainfall occurs during hurricane season. So due to rainfall being highest on this side is for 2 reasons. One, this is where the most of the mountains and the most mountainous topography is going to occur across the island. And 2, because it's during hurricane season when the most amount of rain occurs, is due to the fact that there's stronger northeast trade winds that push moisture to this side of the island. And then due to the orographic effect or orographic uplift that's happening, which is basically when an air mass needs to move from a lower elevation to a higher elevation, and as it's rising in altitude, it's cooling. And once it reaches the top of the mountain, it precipitates, making the eastern side of the island where the highest amount of rainfall is occurring. Also, if we look here in figure 3, you can see that there is a clearer, dry season peaking in February. My results for my Hurricane Maria analysis was that Hurricane Maria produced rain for 45 hours. And if we look here at figure 4A, we can see that this outer rain band of Hurricane Maria is just getting ready to start producing rain on the southern tip of Dominica. In figure 4B, we have here where Hurricane Maria makes landfall. And landfall is just basically when the storm makes contact with land. And then here in figure 4C, we have Hurricane Maria has already left Dominica and is now in a more organized hurricane formation and is moving west towards Puerto Rico. If we look here at figure 5, we can see that there are similar patterns across the island with just peaks at different times. And just for a frame of reference, if you use the legend from figure 3, it corresponds to figure 5. And lastly, for figure 6, this graph shows the total amount of rainfall for each location. So the location that received the most amount of rainfall is Marigot. And if I go back to figure 2, Marigot is located here in this upper green cell on the eastern side of the island. And this is due to the fact that Dominica is located in the northern hemisphere. And due to the Coriolis force in the northern hemisphere, so because Dominica is located in the northern hemisphere, the Coriolis force in the northern hemisphere makes tropical cyclones move in a counterclockwise direction. So I'll use figure 4B to try and explain this. Because tropical cyclones are moving in counterclockwise rotation, the eastern side of Dominica was getting hit by the brunt force of Hurricane Maria and constantly getting hit with rains from the wrapping around of rain bands and wind speeds. Like I mentioned earlier with the orographic lift, this is also occurring over the island as Hurricane Maria is gaining traction and moving west towards Puerto Rico. And also another example of a peak time in rainfall across the island is if we look here in figure 5, this blue peak here represents Soufriere, which is the southern part of the island. And looking up in figure 4B, behind the eye of Hurricane Maria is where there's going to be a lot of more heavier precipitation in this dark blue where my laser is over. And so as the eye of the hurricane moved across the island, all the locations behind the eye are going to be getting hit with this dark blue rain band. The total amount of rainfall in this satellite-based data was well within the National Hurricane Report. The National Hurricane Report was a rain gauge measured over 3 days, and the report that I have shown here is a satellite-based report over a 2-day period. I'd like to conclude with the fact that this is just one example of an extreme rainfall event that has contributed to Dominica's climatology. And for future research, I will repeat this Maria analysis on other hurricanes that produced rain to see what the overall contribution of hurricane rainfall is to Dominica's climatology. I'd also like to say thank you for the opportunity to present at the Mindsets for STEM conference. Thank you.